Now that we've learned what the different types of isomers are, we've decided that the compounds we're looking at could be optical isomers. We know what the definition of an asymmetric carbon is. Now we're going to do some practice where we're going to find asymmetric carbons. For each of these sets of molecules, I want you to do two things. First, I want you to find the asymmetric carbon. We're going to highlight that. And then the second thing I want you to do is decide whether this set is an optical isomer or is the same molecule. We'll start by finding the asymmetric carbons that are in each of the following compounds. So please pause the video while you find those asymmetric carbons and then restart it and I'll go through them with you. Let's start with set A. So I'm going to look at the first, just the left-hand molecule, so we can just focus on that one. And we're going to see that the first carbon here has a CH3 group. Well, CH3 has 3 hydrogens. Those are all equivalent to each other, so that one cannot be an asymmetric carbon. The next one up, where you see all these dashed lines, that one has a CH3, it has an OH, and it has an H. There's definitely 3 different groups. Now the fourth group is a CH2CH3. That is different from just a CH3, so that is a fourth group. That makes this one an asymmetric carbon. Now we're going to go up from there. We're going to ignore the OH and the H because they're not carbons, so they're not going to be asymmetric. We're going to go up from there. We're going to see a carbon with 2 hydrogens on it. As soon as I see those 2 hydrogens, I know it is not asymmetric. And the last carbon on here has 3 hydrogens, so again, it is not asymmetric. Now if we look at the second molecule, you'll see exactly the same thing. We have the CH3. It's on the other side, but it's still a CH3, so not asymmetric. This carbon with the stuff hanging off is definitely your asymmetric carbon, and the other 2 are not asymmetric. Let's look at B. Now on B, we have 3 carbons to look at, so we'll start at the bottom. That one has 3 hydrogens, so that one is not asymmetric. The middle one has a hydrogen, an OH, a carboxylate group, and a CH3 group. So those are 4 different things, so that one is your asymmetric carbon. And we can see that also in the other molecule, that is also an asymmetric carbon. Now we go to the top one. That has 2 bonds to oxygen, and another one to another oxygen. So we definitely do not have 4 different things on there because 2 of the bonds go to the same oxygen. So that one is not asymmetric. So we have only 1 asymmetric carbon in letter B. Now let's look at letter C. Now that's got a lot going on, but let's look at it carefully. Starting from the left-hand side, we see a CH3. That is not asymmetric. The next one, you don't actually see the carbon, but we know that those bends mean there's a carbon there. So it's a carbon, and it has 2 hydrogens on it. That is not an asymmetric carbon. The next one has the group that we just looked at. It has a hydrogen. It has another group, one of them with an OH, and it has a CH3 group. That is an asymmetric carbon because we've got 4 different things attached, so that's an asymmetric carbon. Let's look at the last one and see if it's asymmetric. So if we look at that carbon, it has 2 hydrogens here, so we know right away that that one is not asymmetric. And again, we see the same thing with the other molecule because these 2 are matched sets, so you know that we'll have not asymmetric, asymmetric, and not asymmetric. So now let's look at letter D. When we look at D, we see the first one has a CH3, not asymmetric, a CH2, not asymmetric. We see this one that kind of looks like it might be asymmetric because it's got all that lines on it, right? That kind of gives you a clue. Let's look here. And so that one is asymmetric because we see a CH2CH3, we have an OH, we have a hydrogen, and we have a CH3. And the CH3 is not asymmetric because it has 3 hydrogens. And we see that again on the other structure. So we see just 1 asymmetric carbon in letter D. And we're going to go down. We're going to look at letter E. We're going to see that we have this benzene ring. Benzene ring is not an asymmetric carbon. It has double bonds. It cannot be asymmetric because there's not enough attachments to any one of those carbons. So all of those are not asymmetric. Then we go up from there. We see a CH2 because we see 2 hydrogens on there. So that is not asymmetric. And the next one is asymmetric because we see this benzene ring hanging off of one side, an OH, a hydrogen, and a methyl group. So that one's an asymmetric carbon. And the last one is our methyl group, which has 3 hydrogens, so it is not asymmetric. So we only have 1 asymmetric carbon. Even though there's a lot of stuff there, there's just 1 asymmetric carbon. And again, the other one matches. We can see that this is the only asymmetric carbon. And now let's look at letter F. For F, we can see the benzene ring again, no asymmetric carbons. The CH2 going up, not asymmetric. The next carbon, looks like it has a benzene, a CH3, and a hydrogen. And we see this 3rd carbon chain, but it does not have a benzene ring, nor does it have a methyl group. So it looks different, and so we know that that is our 4th part. It looks like that one's asymmetric. And then we go up from there and we see that we have a hydrogen, and we've got this big group going down, and then we've got something to the left and something to the right. Now those are both CH3 groups. Remember, they have no ending there, so that means it's telling you it's a CH3 on there. So those are both the same. It doesn't happen to be a hydrogen, but the CH3s are the same, so that is not an asymmetric carbon. And again, because those are CH3s, those have 3 hydrogens, are not asymmetric. And we see the same thing over in the second part of letter F, where we have only one asymmetric carbon, and that's the one down below. And that is all of the asymmetric carbons. Now you need to go back through and see which ones are optical isomers and which ones are the same isomers. And then I'm going to see if you can find there are 2 of them that are matched on here. So there's another one of these molecules that has the same formula. They're both the same compound, just written in different formats. Because it's a little more difficult to decide if it's an optical isomer or the same, I'm going to do each one individually. So we'll start with just A. After you return, we'll go over A, and then you can pause the video again for part B.